Hello there, good morning, and hope you are having a great day so far. If you are new to the channel, please subscribe, share, and like the video. This will likely be the last video we'll be doing on this JavaScript introductory series. Going forward, we will now be going to algorithm questions properly and see how we could put all of we have been learning into solving algorithm questions. Today we'll be looking at functions, and the reason why functions are important are because when you're solving algorithm questions, maybe you're in an interview situation and you're solving an algorithm question, you will always be given a function usually, and you have to work with that function. So it's important we understand the functions and the basics of a function even in JavaScript. So what are functions? A function is a collection of program statements that performs particular tasks, which either processes some input data and could return an output. So a function doesn't necessarily require an input or it doesn't require to give out an output, but it should. Within the context of algorithm questions, there will always be an input and there will always be an output. So when you are giving algorithm questions, there will always be something you are giving and there's an expected output that uh, is required of you. So that's basically what functions are. So in the context of algorithm, there will always be an input and an output. But generally speaking, functions must not have, it's not compulsory for functions to always have an input or output. And we see here I said that it could return an output, and the return is key here because uh, the keyword actually to return an output is the return. So when the program sees a return, it's saying, okay, there is an output I want to give. That's what you are trying to, that's what the computer understands by that keyword return. So it stops whatever it's doing to give that output out, and that is, it terminates it afterwards. So functions also provide a means to organize code such that it's broken down into a unit of work. So this is just saying that it's another way of making code more readable, more understandable, breaking it into different units. So if say you wanted to build a a three-story building, so what will you do? There will be a section, there will be a time when you'll be building the beam, doing the beams. There is a time when you are doing the foundation. There's a time when you are doing the roofing. So all of these could be different sections that will now be put together to form the whole building. So in the same way, functions can be broken down into we call small functions that do small things, so that when we bring them together, they can achieve the overall goal. So how do we define function in JavaScript? How does our JavaScript code know that we are declaring a function? So if you check in Visual Studio Code, so the keyword is function. One approach is to use the keyword function. So the function name, this is the basic syntax for the function in JavaScript. Another approach is this. These two are basically the same. Now, where they differ is that, as you can see that this is showing that this is running already. So this by default is going to run. But for if I want to run this other function, I will need to come. I'll say function name, and then it can now go and run it. That's so we have basically this approach where we just write the function, keyword is there, whatever name we want to give our function. It could have an input data, So for example, uh, we have a function that we say hello. So console log. So the input here is name. So it's in name. So let's just give it a name here. So as you can see here, it's console logging it as we expected. Oh, and this is equals to console log. So I could say another function approach. So okay. So this is basically, so as you can see here, we're saying console log. And okay, sorry, I don't need to put the console log. And where the console log everything. Okay, so as you can see here, basically the same thing. Now, one of the major differences between this and this is what we call hoisting. Now, I won't go into details of that, but what basically that means is that I can come above here and I can still call function name, and I can give it another something else, and it's fine. But I can't come. So you see, this is where we write the function. Actually, the function was written here, but I can call it before the function or after the function. But now let's look at if we want to do the same for this. After the function we call it, let's see if we want to call it before it is declared. You see, it's already giving me cannot access before initialization. So that is one of the limitations, or one of the differences rather, when you are using these two approaches. So if you are using the arrowhead approach, now this the lambda approach, so you have to know that you have to call it after you have declared it. But if you are using, so let me comment this out, but if you are using the function declaration approach here, then you can call it at any point. It will, because what the program does is when it sees the function keyword, it takes it up above every other code. So in actual sense, within the compiler, this function, this line is actually below this. So that's what this does when it sees the function keyword here. So when it sees the function keyword, but for this, when you use the lambda expression, you have to call it after and you can't call it before. So that is on that now. So those are the two approaches for defining our function. So to call a function, I have already shown that by, so to call, so we have a function name here. So let me give it a better name. Let's say print print name. So print name. Okay, so print name. So you see here that we are calling this. So this is where the function was declared, but this is where we are calling it. So to call it, we just the name of the function, and if it's expecting an input, we put the input here. So the input in this situation is same name here. So it will now take it into this print name, and instead of this name, it will use whatever we use there, which is some name here. And that's why you see when it comes to log name is actually what some name here. The same thing, you see, this is also calling for this function. This function does not require any input. If it requires an input will be here, and then we can say one input, and then we could just maybe console log that. So you see it will now show the one input. So if you have inputs and you can have more than one input, input 1, input 2, so I will say input 1 plus, and put a space, input 2. We've looked at this previously, so this is second input, and you see that here we have input 1 plus space plus input 2, so input 1 plus space plus input 2, which is second input. So that's basically how we call a function. So when you write a function, so writing a function will not make that function to run. It will have, we will have to call the function to make it to run. So basically, if we do not call it here, or call this one here, this doesn't run. So as you can see, this will not run, this does nothing, it doesn't do anything. So if you want it to run, we have to call it. So we have to, for instance, we call the name of the function print name and pass in the input it's expecting. So it's expecting a name, so let me just give it a name, bimbo. So you see, we give it the name bimbo, and here it prints out bimbo because that's what we're asking of it. So for example, a car has brake, but the brake will not be invoked if the driver does not press the brake in the car. So every car has brake system, but the brake system doesn't just engage itself, although it is there, although the structure is there, except it is invoked, except the user presses the brake, the car will not brake. Now, so function is called by just calling it. So basically, is the name of the function, you just write out the name of function as I've shown us. So for instance, in this situation, print name, write it out, print name, and then whatever input is expected. If it's not expecting input, we can remove the input, and that will be so. Now another important word we need to take note of in functions is the return keyword, because we are speaking with the mind of algorithm. This is we're doing all of this with our eye on algorithm. So this is important that we know. Now if I were to show us, let's say I wanted it to return, to give an output of hello and the name of the person. So let me take this out. So I wanted it to say hello and that person's name. This is what I wanted, but I wanted it to output it. So to give the output, we have to use the return keyword. So by doing this, what happens is that it will give an output. So if I was to show us what the output is this giving us, you see the output is giving us hello bimbo. Now if I remove the keyword, if I remove the return keyword, it's returning undefined, because what it means is that by the time it comes and it doesn't return anything, there is no return keyword anywhere. So what it's actually returning is undefined. There is nothing that it's returning, basically. That's why it's saying undefined. So but if we put the return keyword, it's now saying, oh, we have an output, and the output is hello bimbo. That is so I think so. The return keyword, it's a very it's very important to understand that. So we see here, uh, the function name is say hello, and then we pass in John, and so when we pass in John, it comes here and say hello plus the name John, and then we have an output. So whenever we need an output, when we are writing our algorithm, when they ask for a particular output, we must use the return keyword to give out that output. Without using the return keyword, it doesn't recognize it as an output. So Last thing I want to talk about under functions is the variable scope. So let's say we have two functions, function 1 and function 2. I think it's better if I illustrate that. So let's say, okay, let me clear it. So let's say we have function, we have 1 and we have letter a is equals to 2, and we have another function 2 and let's say b is equals to, let b is equals to 3. Okay, I didn't spell the function correctly. So function. So here, what I want to show us in terms of the variable scope is basically that now you see the a here in this outer function can come, you can use it here, so you can say a. Okay, so let me, okay, so okay, so we can say here that we have a variable a which is 2 and we have a variable b which is 3 in function 2. Now the variable a is visible in function 2, but what if I wanted it the other way around? I wanted the variable b. You see b is not defined because inside function 1 it doesn't have b. Function 1 is inside the inner function which is inside b, so b is visible within here. Yes, but so let me comment this out. So b is visible within here, but b is not visible outside. So if if I come, b doesn't recognize b as, it say b is not defined, but here a is understood. It sees a is within the purview of this function 1, but function 2, what exists there is what, b, so it is not visible to any other function outside of it. On the other side, a is visible in function 2 because function 2 is an inner function. So that's basically that on variable scope. Now, if you have any questions, please you can drop a comment and I will respond as soon as possible. And remember that the best way to get better with anything, especially programming, especially algorithms, is by doing it. Thank you, and let's meet in the next video. Please subscribe, like, and share.